Thank you all for coming. I will be presenting There and Back Again, Reproducibly. And due to the help of one of the members of the audience, my PDF for this talk is actually reproducible, which is awesome. That's been edging under my skin for years. There and Back Again, Reproducibly. It's a little bit of a kind of fluffy storyline and a little bit of plot, and I throw in a little bit of technical elements in the middle and interspersed throughout. So thanks for joining me on this ride. My name's Vagrant Cascadian. I work with the Reproducible Builds project. I've been a Debian developer for some years. I've been using Debian for a really long time, and I've also gotten involved in some other projects that are somewhat related to reproducible builds. How many of you people here have heard about reproducible builds as like a project or a general idea? Or okay. Some of those hands I would have assumed would go up. So when I'm talking about reproducible builds, I'm not just talking about like your software doesn't fail to build. I'm actually talking about a much higher bar for that. Basically, we want, when you take a given source and you use a given tool chain, every time you build it, it comes out identical, bit for bit identical. Not just kind of similar, we're actually talking about identical. And so, unfortunately, the status quo is in the wide world, it's not quite the case. So a number of folks have been working on that. But once upon a time, all software was actually reproducible. Every bit mattered. Things got a little more complicated as we started introducing concepts of compilers and things like that. But in the early 90s, some people thought, hey, we should get the GNU toolchain to be reproducible, and they managed to do so across 10 architectures. And time moved on, and a lot of people forgot about these kind of cool principles. And in 2011 and 2012, both Bitcoin and Tor browser worked on how to make reproducible builds, because both of those projects have a really strong incentive that when people are running the binaries, they have reasonable confidence it actually came from the project and not just some random evil hacker, you know. With Bitcoin, there's arguably money involved, and with Tor browser, there's some privacy involved. So those projects kind of spearheaded a lot of this effort. And then But in Debian, long ago, we kind of heard some mumblings about it on the mailing lists back before the turn of the millennia and a little after the turn of the millennia. But in 2013, folks really began to, kind of inspired by the work of the Tor project and the Bitcoin, were like, what would it take to actually make Debian itself reproducible? And they started exploring some of those ideas. And so in 2014, they started doing systematic testing and classifying all the different types of issues they're encountering. And Debian has roughly 30,000, actually over 30,000 source packages now. So we're not just talking about a handful of projects. So this was a much bigger scale thing than the Tor browser or Bitcoin was, you know, where they have a very specific project. We started looking at okay, 30,000 pieces of software, that's like, represents much of the free software world. And since 2017, we actually managed to get it into Debian policy that suggests packages should be reproducible, which is pretty exciting. But back to our story. So imagine a small little consultant sitting at home, getting their development environment tweaked just so. They put on a bit of tea, and they're just ready to start on their day. They're in between clients, and they're kind of looking forward to a break from things. and they hear a knock at the door. An old friend shows up, a really old friend, and he's like, so, yeah, I just thought I'd drop by, you know, maybe bring some other friends along later. And they started showing up. One by one, various rambunctious friends started showing up. And before too long, we had all sorts of projects, like interested in what we were doing and the last project we worked on, and they wanted us to join in with these efforts. And before too long, we had a rowdy party that was maybe a bit unsettling, but numerous projects had kind of joined on with this idea of reproducible builds. So we started working on the test infrastructure I had mentioned that Debian had set up, and then we started integrating some of these other projects. Since the end of 2018 is when we started integrating some of the other organizations and started sharing different issues, patches, and really focusing on getting things upstream. So a number of other, one of the OpenSUSE developers is really active in just pushing stuff upstream. And that kind of benefits all of the various projects who also use all the same software. And we have a public blog that we now call a monthly report, which kind of describes what's going on in the world of reproducible builds. And there's a lot more opportunity to continue to work together with these projects. So, you know, in some of those early postings, you know, there were just people kind of like, this is impossible, there's no point in even trying to do this, and so on. But we persisted. We kept going. I mean, you don't just like fall prey to the trolls, you know, you kind of wait till the light of day kind of shines upon them. But you find yourself like rummaging around in deep, dark caves, and maybe you get a little bit lost, you stumble upon things, and you find a very curious creature, and you find yourself in a battle of wits. You're stumbling through, like you batter around a few riddles here and there, and you're a little nervous because it's dark and you can't see anything. But this one comes up, and you're like, this is one of those issues. This is one of those things. And all right, who knows what we're talking about here? Anyone? Anyone? No, nobody. Okay. I need more time. Timestamps are one of the most annoying issues with reproducible builds. You take a piece of software, same source, same tool chain, you build it again, and inevitably you didn't build them simultaneously. The timestamp has changed. And so a lot of binaries will embed the timestamp into the actual binary. So of course, that's not going to be reproducible. Another really common issue that comes up is build paths. So you know, you build it in your home dir and somebody else builds it in their home directory, and you end up with different binaries. Time zones is kind of a nuanced variation on the time issue. So even if you manage to get the time to come out the same, if you're building it in two different time zones, the time is not the time you thought it might be. And locales, I had one of the weirdest bugs I ever encountered in one of my packages was it would build reproducibly in all languages, and I'm talking like I tested about 50 different languages, including various Asian and African and languages from all over the world, except for Italian. Italian came out differently. And the reason Italian ended up coming out differently is one of the tools used to build it was embedding the output of LD, and for whatever reason, the only translated string in the LD project at the time was for Italian. And so they said LD de GNU instead of GNU LD. And so that was just bizarre. Like, these are the kinds of weird issues that come up. It's like, why on earth would Italian come up different than the other builds? And we tracked it down, thankfully. And did I mention timestamps? Timestamps are really annoying. They keep coming up. There are hundreds of other types of issues, but I'm just kind of trying to point out some of the relatively easy to understand kind of things that come up. Also timestamps. Please stop embedding timestamps in any of your development projects. It's not a good way to represent this is this build, because if you build the same software later, you've got some random, using it as a build ID is not a great idea. It's kind of fun to work on these sort of things, but most of the time. Sometimes it's kind of like hair pulling, but I'm sure you work on various technical projects. It happens in all kinds of tech-related stuff. So, so you're fiddling around in your Pocket, thinking about timestamps and how it's really like messed with your deliverables on the last project, and you're fumbling around, and you're like, what's in my Pocket? You come across like this thing, and it's like, what on earth is this? And it's just like a little ring or something. Rings have kind of fallen out of fashion in the modern day in a lot of ways, but I think a lot of people have similar objects in their daily lives. You know, it's really portable. You keep it close to you. It bestows magic powers and abilities that you just simply don't have in other ways, such as invisibility. And it's very precious to people, obviously. And what's really similar to the things I think many of you are probably carrying in your pockets is it may use you for its ends. So you might find these amazing magical tools, but turns out sometimes you're the tool. So how can we gain control of our tools? You need to know what goes into them. So you find yourself peering into a dark, deep forest, and you're like, I know there are tons of issues just waiting for me to discover in there, but like, how am I going to like sort through it all? Like, what can I possibly do that will, you know, I've got this one binary and another binary, and I compare them, and have you ever tried to do a binary diff? It's an ugly process. I mean, especially for, I mean, you know, it's a mess. So the Reproducible Builds project developed a tool called Diffescape, and it's recursive and human-readable diffs. So say you've got a jar file, like a Java file. Well, that's actually a zip archive, and Diffescape will be like, okay, oh, you've got a jar file. Well, oh, it's actually a zip file. I can unpack the zip file, and now what's that? Oh, you've got a bunch of other files inside of there. Oh, those might be some other kind of archive format, and it recursively unpacks them and then tries to render a meaningful diff. It's useful for locating reproducibility issues between two different objects. Not really useful for determining if something is reproducible, because the simplest thing to do that is just using a checksum algorithm such as SHA-256 or if you like stronger checksums, you know, whatever. I mean, you can even use MD5 sub to demonstrate that they're not reproducible, right? But it's used for analyzing why they're not reproducible. So you might be able to see a timestamp embedded in something or a version. So this is just a clip of some example output, and if you look at the line near the bottom, you can see the version of the software was different. So of course it's going to produce a different binary object. So this is like a very hyped up diff. And people have used this for things beyond reproducible builds. So if you do a security update, you want to make sure the only thing that changed is relevant to what you're trying to fix. Similarly useful for code refactoring. If you refactor a bunch of code, in theory, you might even be able to produce an identical binary. And this can help you determine, well, what exactly did come out different? And so it supports a few different file formats, you know, and it's relatively easy to add more. It's written in Python. It's very modular, and with a few lines of code, you can typically add support for a new file format if you know how to meaningfully represent that to human eyeballs. What's that? Can it do multi-way diffs? I believe it's only two-way diffs. You can typically diff objects or even directories. But yeah, I'll get into a little more. So it's available in a lot of common Linux distributions, also on PyPy and Homebrew and other not-so-Linux distributions. And there's also a web interface if you want to just like upload 2 files to try.diffescape.org. You can kind of just play around with it and see. I used to use this to compare my presentations as a great example, but now that I've fixed that problem, I can't do that anymore. So you've been working on Diffescape, on comparing some objects, and you might encounter some things. You know, maybe some bugs, and might wrestle with those a bit, or maybe use some magic tricks you found in your pocket somewhere. But in the end, you want to be like, how can I build out some issues? How can I root out some ideas of like, what's wrong with this software? Why is it not building? And so we built this tool called ReproTest, which helps you introduce variations into your build process. So you can basically, it'll do a control build, and then it'll do a second build where it tries to vary the time, vary the build path, vary the username used to build it. It has various ways to create a virtual environment to help you vary the build environment in ways that shouldn't affect the build, but all too often do. And this is available on salsa.debian.org under our Reproducible project. So, and the really cool feature about it that is it can actually bisect in a loose sense. It can go through and systematically try out the different types of variation and give you a hint at which exact type of thing is actually likely your reproducibility issue. And it'll also run Diffescape at the end if the different objects aren't reproducible. So that way you can get here's exactly what's different. So it's kind of like, you know, you throw some stuff in a barrel and you roll it around and it gets all disoriented inside. So yeah, that's basically what RepoTest does. And one of the most important concepts of like, why do you even need reproducible builds? Well, we're looking for backdoors. Not just backdoors in the source code. Reproducible builds isn't really meant for solving that kind of a problem. You can audit that by looking at the source code. But what it's useful for is looking for backdoors in the tool chains. So the compiler you use, or whatever tool you use to render your jar files into compressed jar files, or whatever the heck jar files get used for. We're looking for backdoors because that's where, with reproducible builds, when you're comparing 2 binaries, a human can't meaningfully tell the difference between the 2 binaries. And the tool chain can be used to inject whatever it wants. So yeah, okay, you gave me this source code, but I'm going to do these other things and put them into your binary, which can be used to inject all sorts of ugly problems. So the best way is to build things reproducibly. So maybe you find a backdoor and you encounter something terrifying. Perhaps it was put there by some large, powerful entity that is beyond any sense or reason. And therein lies the monster. So using these tools, we can actually detect and possibly even prevent the incentives for very powerful entities to put pressure on developers to modify their builds in ways that are basically impossible to audit. So the important thing with reproducible builds is that it can be independently verified. So I do a build and I can attest, I did this build, this is the source I used, these are the binaries, and then you can attempt to take that information and produce the exact same build. and then somebody else can do it. And what's really important is that ideally at some point we have actually mutually hostile actors all running verifications on build and coming up with the same results, because then, if the NSA and maybe some Russian organization are like coming up with the same results, yeah, maybe that's trustworthy. And maybe you get the Civil Liberties Union doing some builds and the EFF and various parties that have no real reason to collude. If they can all come up with the same reproducible results, you have reasonably high confidence that the binaries that were produced from the source code are the intended result of the source code, rather than something that's been tinkered with at the toolchain level. So, having dealt with that, you head back home, you stumble upon all the adventures you had along the way, and everything's nice and pleasant again, right? Well, you brought some things home, so we've come to an end of a sorts. But who's watching? Who is left there on your precious little devices that you carry with you everywhere? How can you detect these things? And really, we haven't achieved reproducible builds. In Debian, we've managed to come up with 93, 94% of packages that we know in theory how to build reproducibly, which is a lot. But there are various important packages like GCC, which is a compiler used for compiling much of the C code in Debian. It's not reproducible itself. There are a number of other things. So it looks good, but we're definitely eyeing up some last mile problems with this. Like, yeah, we solved all of the easy problems, and we're 93 to 94% reproducible. But 7% of 30,000 source packages, that's still a very large number. And there's new software always being developed. I mean, every day there are hundreds of new projects getting released into the wild, and for good or ill, that's happening, and you have to keep on top of that. And really, we've only demonstrated reproducibility in theory. The packages actually in the Debian archive, we don't have processes to validate those packages. Our test infrastructure basically takes the source code, builds it, and then takes the source code and builds it and compares against our two builds. But they may not necessarily match what's in the Debian archive. Although I did do a little bit of testing last year on the Debian base system, and we did manage to get, I think, 59% of a very minimal Debian system were actually verified at least once. But the hard work is really getting into making builds reproducible in practice. So we really want to see that, as I was talking earlier, about mutually hostile actors coming to agreement on something. Because when you can do that, we've got greater confidence that it's legitimate. We need a meaningful end user interface. Like, okay, so the software is reproducible in theory, but how does that matter to the people actually using the software? So we need to move forward on work with that. There's a huge amount of work to do, and this is my moment to make a plea for help. We would love you to contribute in any way you can. But also, there are huge other projects going on. What compiler do you use to build your compiler? And how can you trust that compiler? So this is an old problem, decades old. Back in 1984, Ken Thompson did a paper called Reflections on Trusting Trust, which I've often referred to as the trusting trust attack, where he demonstrates if you compile a compiler with a compromised compiler, you build a compromised compiler, and then it compiles itself with it, it can inject vulnerabilities into the compiler that then you will never see in the source code, and it can actually recompile itself and continue to inject those kinds of vulnerabilities into the compiler, which is basically a pretty fundamental security problem that affects all software. And there's been very little done over these decades to actually address it because it's kind of hard. But in the early aughts, David Wheeler did a paper on basically the primary strategy thought about to counter trusting trust, and it requires reproducible builds. So, and the basic premise is you can build a compiler, and then you develop a very minimalist compiler, and then you use multiple different compilers, all with different histories, to produce a bit-for-bit identical minimalist compiler, and then you can build confidence that that minimalist compiler isn't compromised, and you use that to bootstrap a much larger and complete compiler system. And that's really hard. But what is really awesome is in the last few years, people have actually been working on doing that. So GNU Mess, and there's also a project, I forget the exact name of it off the top of my head, but there are a number of projects around where you bootstrap a very minimalist compiler, and then you build it with different compilers, and you can bootstrap all the way up to a full-blown Linux distribution from that kind of trustworthy seed. And one of the things is, one of the projects is a very, very minimalist subset of C written in binary hex code that's well commented. And so that is effectively auditable, and you can build that. And once I start asking him about some of this stuff, he's like, well, yeah, that's a good start. But we'll be like moving on to like punch cards and building out the actual hardware to build this bootstrap seed. So there are very ambitious plans afoot and amazing progress in that direction. So yeah, we would love to have people get more involved. And we have an annual summit. It started in Athens in 2015. We've had a couple in Berlin, and also in Paris, and most recently Marrakesh. It's pretty exciting. So we love to get together and share ideas and bounce ideas off of other projects. I'm most familiar with Debian. I've started working a little bit with GNU Geeks. But we love to come together and share ideas, and it's a lot of fun. And we're not sure exactly where it's going to be this year, but probably somewhere in the ballpark of October, November, December. We'll look to have like more or less a week-long session, and we have like some intensive days where we just discuss issues, and then some days on both ends of those days where we actually dive in and try and solve some things. So yeah, we stand on the shoulders of giants, and women and men and people of all genders, and elves and dwarves, wizards and hobbits, and beings beyond our current imagination. And we welcome you. And we welcome free software. So thank you for your time and contributions and listening to me ramble. It's a very long project, and we would love for you to join us on the next legs of these involved journeys. So any questions? Oh boy. All right.
I'm wondering if you can briefly summarize the issues of reproducibly building GCC, if you know them.
No.
Okay.
Yeah, GCC. I haven't personally looked too deeply into that particular issue. A year ago, I could have answered you better because I tried looking into it. But yeah, I can't really say at the moment. There are a wide variety of issues of things that tend to get embedded in like dwarf objects that GCC produces. And GCC refused some of our best efforts at getting a patch to strip out build paths. So I can speak more to what GCC produces than GCC itself. Yeah, build paths are one of the issues that I've kind of put on the back burner because it's so easy to work around using a chroot where you can build the thing in a predictable path, and that solves a lot of issues. The number with build paths is, with build path variations, we're looking more at 84% reproducible, and without them, it's more like 93, 94%. So if you keep the build path stable, that solves 10% of 30,000 packages, so not insignificant. But yeah, I have a question for you, actually, because I know a little bit about what you do. Have you found reproducible builds useful in like license compliance related stuff?
So we would, if any projects that we were assessing for compliance actually used reproducible builds. It's something that so I work at Software Freedom Conservancy, and I do GPL compliance and enforcement work, and one of those is confirming that the source code we receive from a vendor who's usually redistributing GPL software corresponds, which is the term that the GPL uses, to the binaries that they give us. And so an easy way to check if the binaries correspond is if they are exactly identical. And so reproducible builds would make my job very, very easy in that sense. But right now I kind of have to like guess a little bit, like, oh, are the strings similar? Like, is the file size similar? Okay, it's probably similar. But like a vendor who's trying to slip something past me could very well do that because it's difficult to determine this. So I'm very excited about reproducible builds because it would make these things a lot easier going forward. So that's just one example of where this is really nice to have for verifying GPL compliance.
So I guess a question: do we have how many people in the room like maintain a project that at least one other person in the world uses? Yeah. Have you tested whether any of your software is reproducible? Okay. Do you know how to find the information about what yeah, okay. So, all right. Yeah. Let's see.
What about the interpreted ones? I mean, is there any concerns there? Because so it's pretty obvious with compiled languages, but most of my stuff's interpreted. So it seems like that's an easily solvable problem, or is it not? What are the warts there?
Yeah, there is it's a little, so many interpreted languages do still produce a binary object as part of the running the code. So it would be interesting to explore that. I don't know that we have done it. Like in Debian, most like Python packages, for example, the package itself doesn't ship the bytecode compiled stuff, but at package install time, that stuff gets generated, and so we kind of work around that issue in a sense. And I don't know that people have really dived in to explore those kinds of issues. But like with like PHP or JavaScript or something, is that more what you're getting at, or? Well,
yeah. I mean, I know that you, whenever I talk to you about this, I present things to you, and then you always show some insight that I haven't thought of. And so I'm thinking, like, if you can trust the Python compiler and if you can trust the Python source code, is that good enough? And I'm guessing the answer is no, because of something I haven't thought through yet.
And the other reality is reproducible builds can't guarantee anything. It merely, like all security issues, it's a degree of confidence, right? It gives you a reasonably strong confidence, and the more people who independently rebuild something, the greater the confidence factor is, or whatever. So, yeah, I in a sense, we might never be fully reproducible. Like, maybe I could take this back a ways. Yeah. So we've got, I don't know if you can see on that chart there, but there are a few notable dips where it goes back down. That one kind of like right in the middle there, that's when we're like, oh, we should actually vary build paths. And so it went down, and then we fixed some issues and added some more software and stuff like that.
What does that graph represent? I don't know.
Great question. So this is basically the historical representation of successful reproducible build tests in Debian. So the green stuff is good, of course. And what's that?
How much time is this? Is this a year?
I think this is 2014 to present. I updated this just a few days ago. The green stuff's all reproducible. Orange is it built successfully but not reproducible. Red, I think, is it fails to build at all, which is a kind of annoying problem. And then there's some other miscellaneous weird states that are barely represented there.
Are there like completely reproducible, like there's things like BusyBox and there's TinyC compiler and there's other things like this which I think are probably lower bars. And so I'm wondering, are there completely sort of embedded reproducible systems that you could use today?
I know OpenWRT has some images that are fully reproducible, so that's pretty exciting. So in that's the only one I can think of off the top of my head. We've been working a bit on reproducible images in Debian, for the installer images or live images, but that's there are a lot of maintainer scripts that run at package install time that can do arbitrary things in unreproducible ways. But yeah, OpenWRT is one of the most exciting ones. I think some core boot images might also be, if you're into that sort of thing, low-level boot firmware. On one of my other laptops, it's a Pinebook, and several of the boot firmware parts of it are actually reproducible. And one thing about this graph is it shows in Debian we have a source package, and it can produce an arbitrary number of binary packages. And in a lot of cases, like the Linux source package isn't as a whole reproducible because a few of the packages, like the documentation package, aren't reproducible. But the actual binary that's running on the system actually is reproducible. And while you really do want your documentation to be reproducible as well, I've started questioning whether only focusing on the whole source package, from at least in Debian, is the right thing to produce a graph on. And I'd be curious. I'm thinking about exploring producing a more fine-grained graph, actually.
So one adjacent question to that. I know that when I worked in SEC, there were a bunch of certifications for different kinds of security clearances and things like that. And I can imagine that this is a bar that somebody has to pass, and that you can then certify something as such, and then maybe perhaps it can only be used in certain high security places. Is there any effort there to define what reproducibility means and to qualify it and things like that?
Right. I don't know about we've vaguely talked about some certification. I know, I think like in various parts of Europe, casino regulations require their gambling machines to be reproducible, which kind of makes sense, I guess. but yeah, so there are some interesting, there are requirements to do reproducible builds in various ways, but actually to make a certification is something we've thought about, but you know, our core team is only like 4 people. Some of us work part-time, and then we've got a bunch of other people working on it. So setting up a certification program sounds like a pretty big labor-intensive project that we ourselves might not be the best position to set up, but we would love to help people interested in working on that.
The related question to that is, I know that in cryptocurrency and in SSL, there are at least, they're not the best tools, but there's ways of verifying that something exists without having to do the work yourself. And so is there work on verification tools for me to, let's say I claim that this is reproducible, and then without having to sit here and then run the commands and the build process myself for the next 18 hours, is there a way for me to then verify that it is what you say it is?
Right. That's basically what we're still kind of in the infancy on that side of things. We're looking at how do we expose the reproducibility information to the end user? How do we make it easy for an end user to perform a verification? But it's still very much in the infancy. Given where we're at, and that I see this graph gradually edging up, occasionally dipping down again, I think that's where we really need to direct the next energy, because unless we actually have this stuff exposed to people and making it meaningful to people, like journalists are like, well, I want to make sure nobody's hacking my systems. For this to be a tool for that, we kind of need an interface for it. So I think that's some of our most important next steps for reproducible builds.
Yeah, I think that you could borrow some of the cryptocurrency technology that's been developed over the past couple of years in order to achieve that.
Oh, to answer your previous question,
Yes.
About any useful tools you can get that are built reproducibly, the Tails live image is reproducible, and that's the privacy-focused Linux distribution. Their ISO is actually reproducible, and they do have, actually it kind of merges these two questions. They have instructions for how to go about verifying it and what the process is. So,
Is there any work on doing it for hardware?
I don't think so. The bar for that is a lot higher, because you're starting to deal with like scanning electron microscopes and stuff.
Well, no. So, for example, let's say that I get like an ARM v7 chip from a Chinese manufacturer, and that they assert that it follows the ARM standard, and then, but they put some kind of backdoor in there of some sort. Like, I understand that, but, I mean, is there some kind of way of verifying that anybody's looked at?
Right. I mean, in a very loose, informal sense, one of the main things I've done with reproducible builds is I have a build farm of like 20-some boards, all little ARM boards, and I tried to get as many different vendors as possible in there. So unlike your typical like rack mount system where you want nice racks with all identical hardware, I'm like, let's go the other direction and get a bunch of crazy stuff. And the theory is that maybe we can find differences produced by different systems. That shouldn't happen because you're targeting a specific user space ABI, but I don't think we've had the resources to actually meticulously go through and see, oh, this board is consistently producing a different result. But in theory, that's one way you could kind of sort of do that. Obviously, it's not going to catch all types of backdoors, but
So what you're saying is that if I have this very complicated system that I can build that takes maybe a couple days of work, and then I do it on this chip that I don't trust, and it doesn't do what I know is reproducible, then I can question the chip.
Possibly.
Oh, interesting.
It's an avenue to explore, for sure. You could hold that all day, huh?
I think you win the award for most questions from a single audience participant.
Any other curiosities? Yeah.
It's quite all right.
Do people know where to go next? Did I hammer that home well enough? You know where to go for more info? Excited about diving in? Oops, there we go. All right. So Reproducible Builds, reproducible-builds.org is the main kind of central point for our development of this stuff. We also, I was at Scale here for Scale 15, and I presented about reproducible builds, and one of the most notable changes since then is we have a logo. And I'm pretty excited that the logo is both functional as a logo and actually embeds meaning, in that we have like a starting point and it goes different directions and it converges on the same place, which I'm pretty proud of that aspect of it. If you like the logo, you can take some logos home with you. Up here at the table, we have some stickers and even some buttons. If you like pokey, sharp objects, we have those. So yeah, I think unless there are any last burning questions, you're just gonna come here and like talk to me after the talk. All right, we have a taker. Excellent question. I should have had that in here. So the question is, have there been any actual historical breaches that reproducible builds could help with? And the answer is most definitely yes. Interestingly enough, like with all this stuff in, Tor and Bitcoin and the Debian project started really looking at this, 2011, 2012, 2013. And in 2015, the Xcode Ghost vulnerability was discovered, which was a compromised toolchain targeted at Apple development. And it compromised something like 4,000 applications in the Apple App Store. And Reproducible Builds is exactly positioned to address those kind of issues. So Xcode Ghost was one of them, and Xcode Ghost is really interesting in that it very closely parallels the type of attack described in some of the Snowden documents, in that it pretty much matches the description of an attack that they were working on out of some of the stuff that Snowden leaked. So it's definitely not just a theoretical attack. There are other cases where I think reproducible builds would have helped out in a slightly different sense, like with the Volkswagen emissions scandal with their software. They made software that reproducible builds might be able to help detect that sort of thing. What's that? The SSH entropy bug. I'm not sure that reproducible builds would catch that, but that is an excellent example of how a single bit flip in a binary can produce different results and result in security issues. So. Right. Yeah. So that one wouldn't really be addressed by reproducible builds because it was ostensibly a source code issue. But one that is interesting that points out that similar is not necessarily good enough is there was like a bit flip in SSH once, and it created a root exploit, a remote root exploit in SSH, and it was a single bit difference. So similar, what's that? No, this is well before Heartbleed. It's in one of my previous talks. I forgot to mention it, but
Could you repeat the example that he brought up? Because I didn't get the mic to him.
he had asked if reproducible builds would help with detecting the SSH bug in Debian, in which they generated the keys using a number space, I think basically equivalent to the number of available process IDs, which is not what he said exactly, but that's what I'm remembering about the bug, which is a very small pool of entropy. And my response was that reproducible builds wouldn't help with that per se, but it reminded me of another one related to SSH that just points out how small differences in your binary can result in root exploits. I mean, and I think anybody who's done any sort of security work knows that small differences can make worlds of difference in the end result. So yeah.
With a fraudulent commit to the Linux kernel that one time. Oh, you wrote that one? Yeah, so there was a fraudulent commit to the Linux kernel where somebody changed a double equal sign to a single equal sign. And somehow they stole the credentials for this. And within that commit, there was valid patches that was done in the style of the actual coder. And then within the patch, they changed a UUID double equals 0 to single equals 0. And it was caught.
Yeah.
And the guy said, no, that wasn't me. I wasn't there at the time, blah, 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 blah. And
That was caught because it didn't match the Git hash.
oh, yeah. But there was a long, but here's an example of something like that. Of
Right.
a single character difference. And
Right.
it's by somebody who you thought that you could trust, but somebody had stolen the credentials. And even if you look over it,
Right.
you look at it and you say, well, this looks like a valid
Yeah.
code.
So, and that's the fundamental thing with reproducible builds, is it gives us some way to audit the binaries, because source code is inherently auditable. We may not always catch everything, but it's reasonably possible with sufficient resources and energy to actually audit the actual source code, as compared to binaries, which it's a much higher bar for auditing.
I have one.
Uh-huh.
So, given the numerous avenues that attackers leverage and the ongoing cat and mouse game, would you say it's a fair characterization that a completely new paradigm is needed in order to thwart the onslaught of an ever-growing body of attempts and threats to security?
That's a pretty broad, open-ended question. I mean, we always have to adjust.
I mean, at the essence, it seems like we're losing at this point.
Sure.
Yeah.
Yeah. In many ways, we're losing, but we're having some victories. I think reproducible builds is one tool to help it nudge us more towards a safer environment. But yeah, there are a tremendous number of problems, and reproducible builds is one tool to help address some of those problems. It fundamentally works towards being able to audit the binaries as opposed to the source code. So it gives a path between this source code produced this binary, and I have reasonable confidence that that's the correct binary. It's a classic garbage in, garbage out. If you put in bad source code, you're going to get a binary that does bad things. But if you can trust you can audit the source code, that's a separate issue. So yeah. So don't apply the wrong tool to the right problem. But anyway, I guess I'll wrap it up then. And thanks so much for coming. And have a wonderful rest of your weekend.